All right. So Ben, when people talk about allulose, there's obviously a common discussion on the GLP-1 effect, on the glucose modulation effect, but there's also an impact on fat oxidation as well. At least it seems. I think you and I have both looked at the same paper, and it seems kind of interesting that it actually could influence our rates of fat oxidation.
Yeah.
How does that potentially happen?
Right. Well, in fact, I actually think you mentioned a leading candidate at least. So there were two things probably that explain this. And just by way of speaking with some authority, we just published a rodent paper that we looked at this. We actually measured at least mitochondrial function. So the kind of most simplest, purest form of metabolic rate in tissues, multiple tissues. And not only did we find that these animals had an option. They had a Western diet, which is high fat, high carb, very much like the global diet that everyone eats from Singapore to the US and everywhere in between. So they had this Western diet, and it was sweetened they had water with stevia or water with allulose. And the animals that were eating the Western diet, of course, got much fatter than the animals eating the standard animal diet. They stay very lean animals. But the animals that were eating allulose were significantly leaner than the animals getting the stevia with their Western diet. And they ate a lot less. They also had a much higher metabolic rate in their fat tissue. So what we found was by measuring some ATP numbers, we determined that there was a greater degree of mitochondrial uncoupling in the adipose tissue of the animals that were getting the allulose. Allulose, we found significantly greater mitochondrial uncoupling in these animals. It could have been a function of the higher ketones, because they were just eating less, they had much better insulin control, but also likely a direct effect of GLP-1. So GLP-1 has multiple effects throughout the body. And this is evidenced most especially with these GLP-1 based weight loss drugs like, Wegovy and Ozempic and all these other ones nowadays. One of the reasons they do cause substantial fat gain, and I do not mean for this to sound like an open endorsement of them, is that GLP-1, when it's activated, or that pathway is activated in the case of these drugs, it does cause direct fatty acid oxidation. And so it has a direct effect of stimulating fat burning. In fact, this is one of the reasons why, let me back that up. It does help with beta oxidation, but it facilitates lipolysis first. So it has a direct effect on the fat cell of stimulating lipolysis, GLP-1 does, and then it has a direct effect at stimulating the burning or the oxidation of those fats as well. Dr. Mark Friedman, one of the leading authorities in obesity research for decades, suggests that actually could be one of the important components of the hunger controlling effects of GLP-1 drugs. That if you are stimulating fat cells to release more fat, the brain senses, even if the brain's not using it, the brain can monitor that energy, and it says, oh boy, we are flush with energy right now. We don't need to eat as much. And so that could be one of the mechanisms whereby GLP-1 is suppressing appetite, helping the person lose more weight by eating less. So to bring it full circle, I do think you'd mentioned that even in the question that one of the mechanisms whereby allulose may particularly be helpful for fat loss is probably the GLP-1 effect.